This is a video on using Newton's method to find an intersection. The question states, use Newton's method to approximate up to 3 decimal places the x value of the intersection of the curves y equals cosine of x and y equals 2x minus 1. So let's first look at the graph of those curves. And we can see that they indeed intersect at a point. That point has an x-coordinate pretty close to 1. It's not equal to 1, but it's close. So I'm going to use Newton's method. And the big formula for Newton's method is we obtain the next value of x by plugging in x minus f of x over f prime of x. So let's get some equations and figure out what f of x is. But before I do that, remember that this point has an x value near 1. So my initial guess will be at x equals 1. When we want to find an intersection of two curves, we could set the equations equal to each other. 2x minus 1 equals cosine of x. And then we can subtract off the cosine of x to get 2x minus 1 minus cosine of x equals 0. Try as you might, you're not going to be able to use algebra to solve this. This definitely needs Newton's method. So I'm going to allow f of x to be the left-hand side of this equation, 2x minus 1 minus cosine of x. I need f prime of x because it's in Newton's method formula. And f prime of x is the derivative. Derivative of 2x is 2. The derivative of cosine is negative the sign, so negative, negative, the sign is plus the sign, and the 1 goes away. So at this point, I can plug it into Newton's method formula, and I know that the next value of x is going to be x minus f of x, here's f of x, over f prime of x, and here's f prime of x. So I'm ready for a table. I will have my guess number, my x value that I'm plugging in, and my Newton's method formula that gives me my next x value. So remember, my initial guess was 1 because that was pretty close to where they intersected. So that's my n equals 1, x will be 1. And I used a calculator, and I plugged in 1 into the n of x formula, and I got 0.838. I'm keeping 3 decimal places because that's what I'm asked to do. So then my next x value is 0.838. So this is called a recursive function, where you take the value of x, you plug it in, and you use what you get for the next value of x, and then you keep going. So now I'm going to plug in 0.838 into x in our Newton's method formula. And I got 0.835. And that will be my next x value. And then I need to plug in 0.835 into my n of x function. And again, I got 0.835. And that's wonderful, because when we repeat, plugging in it for 0.835 is going to get 0.835 forever. So that means that we have up to 3 decimal places, we've converged. And our conclusion is that the point of intersection occurs up to 3 decimal places at x equals 0.835. And I'm done with the problem.